I'm here with Dale from Aphi Projects and we're on another fine passive project. Just completed a blower door test and we've got 0.32 ACH, amazing results. Dale, take us inside and let's have a look at the project, mate.
Thanks very much, Jamie. Good to have you here.
Thank you. Okay, Dale, so we've got an amazing CLT project here, mate, but just educate everybody on how this process happens. I'm looking at some amazing drawings and this process, but how does someone go about a CLT and what do they do and how do you help that process?
Yeah, thanks, Jamie. It's been a pretty long process, this project. It happened over a 4.5 year period, and it all started with design and documentation, and obviously primarily design. We not only build, but we're designers also. And it's a really critical thing with Passive House. It was the reason that we got into design and build, was because when you introduce Passive House into a building system, it needs to be thought about really early in the process, and it needs to be designed in to every aspect of the building. And so what we do is we meet with the client and they engage us from concept design or sketch design at the very first stage. We then develop the aspirations and the objectives for the project together to ensure that on a day like today, where we're handing a building over, we achieve the airtightness that we've achieved, Passive House standard. All the CLT in this project in particular is super important that all gets designed in really early and is thought about, long before the build ever commences on site. That really the design process, the documentation process, being really diligent with that is what makes a building like this successful and what makes achieving Passive House really successful. This project's got a basement, so we obviously had to get up, we didn't want to use CLT in ground for obvious reasons. So obviously get out of the ground. That platform at ground level needs to be spot on. The CLT obviously is much easier to install if everything is dead level. Plumb and true.
Of course.
So you spend quite a bit of time making sure you get that spot on.
Yep.
And if that is right, then the CLT install is just a breeze. And so we went from literally having a structural base, to a watertight building envelope within 2 weeks.
It's incredible, isn't it?
Yeah, it's amazing.
When you compare conventional construction, you could be looking at 6 months. And whether you've got a long where your framework, everything's exposed. That's right. You're closing up this in 2 weeks. That's incredible.
That's right. And look, we do conventional framing as well. Obviously, it's a CLT. It is a bespoke product, I suppose, and it's not for everyone, but it is much easier. And when we are doing stick framing and you're caught in the weather, it's inevitable that you're going to be in the weather at certain times. It's almost impossible to install something on an on-site situation without having some weather implications.
Correct.
But the CLT does limit those and does expedite that process. So once shop drawings are signed off, you're looking at sort of a 3 or 4 month lead time for CLT to arrive, which usually works pretty well with the amount of time we need to spend on site to prep for it anyway.
Okay, well, let's have a walk through and show us some of these finishes. And look, we're just standing in this kitchen. We've got this induction cooktop and this looks like some type of vent. Can you explain this to me, mate?
Yeah, so we've got a downdrafting range hood here with charcoal filters. So it's a reticulated system. Obviously, when you're cooking, you're generating energy. What's the point of just sending that energy out of the building? Might as well try to retain it in the building and utilize it to offset our heating demand.
Sure.
So yeah, like the charcoal filters, reticulating the air back into the building, then any residual smell or a little bit of particles that are left over can also be treated by the extract of the HRV, which is in the kitchen as well.
So where's this extract to?
It just extracts in the kicker down here.
Right, so it's incorporated in the floor there.
Yeah, so it's down drafting straight back down into the kicker and then back out across the floor.
Fantastic. And I couldn't help but notice the design in the top of this bench top. What's this?
Yeah, we've just got some little inbuilt bins and some lids on the Corian bench top here. The owners were pretty adamant about having kind of all their bins concealed, but being able to access them very easily. So we worked with them to make sure that all of that could be designed in and nice and neat and tidy.
It just seems like it's been a whole thought process before the build, really.
Absolutely, yeah. As I say, it was a couple of years of design before the job actually started. And in an ideal world, if you do the planning correctly, it makes the execution pretty easy.
Okay, Dale, so just touching back on these sliders, mate, talk to me about this, because I mean, this all looks CLT to me, but I'm looking at internal cavity sliders.
Yeah, so the CLT manufacturer also produce board products. You might actually be able to see it there. This is a 13mm, what's called 3-ply, 3 lamella of plywood, European spruce ply. So as part of the design process, we strategically build in primarily interior walls that are hollow core walls, essentially, like stick-built walls, like conventional construction, and then we line them with the 3-ply so that you get the same effect as the CLT, but you have the ability to install cavity sliders or services, and yeah, you give them a bit of a push and they recess back into the pockets really nicely. And it just gives a nice refinement to the building and to the interior finishes. And
Mate, that's an amazing touch, and it's testament to the tradesmen that have worked on this project, mate. Fantastic.
Yeah, we're really lucky that we've got really great trades, and all of this sort of work, the attention to detail that goes into it, and the diligence is what makes it, you know, like it's what is able to get a regular building to passive house standard, is a higher level of attention to detail and diligence in workmanship. And that's what originally attracted me to it back in the day when I first came across it in Germany. And yeah, hopefully we've managed to carry it on in Australia.
Yeah, I think so, mate. I think well and truly. Your client must be ecstatic, mate.
They're pretty rapt, yeah, absolutely.
You touched on before, we've got the HRV system, obviously, which is paramount for a passive build, where we've got vents on the ceiling, which is a centralised system throughout.
Yeah, so in this building we actually have a suspended ceiling. So the CLT is the structural roof,
yep,
and it's on a 3-degree pitch.
Yep.
It's got a weather-tight layer over the top of it.
Yep. What is that weather-tight layer on the top?
It's the Proclimer Hero.
Yep.
And obviously fully taped and sealed and welded,
yep,
in accordance with the installation instructions. And then there's a batten, obviously a vented cavity and a batten system over the top of that, and then our roof sheet.
Colour-bond roof or something like that.
Yeah, exactly. Yeah. But underneath that, we've got a suspended ceiling. At the high end is about 1 metre deep. At the low end is about 400 or 500 mil deep, and that's packed with insulation. So that's where we get all our insulation value for the ceiling, is on the underside of the CLT. And then we get this suspended ceiling because part of the design brief here was that the ceiling line and the eave line, we wanted all in the same alignment, and we wanted the glass to extend all the way to the ceiling line and provide us with this sort of seamless indoor-outdoor effect in the ceiling, which is what's been achieved.
And you can see that's all been thought out before construction.
Like, absolutely, yeah.
It's all just meticulously thought out. So before you build, you know exactly what you're trying to achieve.
Yeah, absolutely. And it's even with passive house, it's even more critical that those details are thought out early, because, you know, we've got pelmets for blinds built into the ceiling here. They have to be negotiated around airtightness. So we actually have an airtightness layer here. There's Intello, Proclimer Intello at the ceiling level here, about 130 mil above what you see as a finish level. And the reason that we have that too is because the insulation is on the warm side of the CLT. There's a risk of condensation there. So we needed that vapor barrier on the warm side. We had an airtight envelope with the CLT, but the Intello at the ceiling level obviously helped with that a little bit further. And yeah, but you need to be able to design all of these junctions and all of these details in long before it ever comes to site, so that you know exactly how you're tackling it when you're executing the airtightness.
Windows and doors are a big part of a passive build. Talk to me about this window here, mate.
So along with the CLT, we import the windows out of Europe as well. So these windows are made in Austria by a manufacturer called Frasinger Fensterbau. We've worked with them for a while now, and they obviously make a really beautiful thermally broken window, super energy efficient window. These windows actually have a coating on the glass that increases the solar emittance into the building, and particularly on the north, because we were sort of teetering on the limit of the 15 kilowatt hours per metre squared annually for the heating demand. By being able to bring more solar in on the northern aspect of the building, we were able to reduce that down to about 14 kilowatts per metre squared annually. The glass is actually designed very specifically for whatever aspect it's on. There's a lot of south glass in this building, naturally so, being that we're on the surf coast in Victoria and everyone wants to look to the ocean. So the glass on the south side of the building has as low a U value as it possibly can. Whereas the glass on the north side of the building has a low U value but a higher solar heat gain coefficient to allow more solar radiation into the building and reduce the heating degree hours required.
Because this has all got to do with the passive modelling, right? So that's where all of that comes into the design and the review. And you know, we are very coastal here. Like
Absolutely.
this is an area that is going to be continually buffered with winds throughout all of the seasons. So, you know, it's crucial to have a good air tightness envelope. Can you just show us the window and explain to us that?
Yeah, so being European, they're all tilt turn, so obviously have the ability to fully purge the building when we get the cool. Like one of the great things about being in a coastal region is that 95% of the year in summer, 95% of the cooling degree hours, you actually get cool changes come through late in the afternoon, and so you can actually open the whole building up and get as much ventilation as you like and just purge the building. But when you don't want to purge it and you just want, you know, normal ventilation, you have the tilt position, which you can then leave these windows in that position when you're out of the building, go away, like they're
fantastic,
completely secure.
isn't it? It's just a multi window that's got, you know, complete thought in the design process. Because you're right. I mean, passive is all about air tightness, but in certain times of the year, you want ventilation. You want natural ventilation. You want to open your house up to the environment.
It's something that we get questioned a lot in Australia because we have such a mild climate for the most part, and people are kind of a bit concerned at times that passive house, we have to lock all the house up. We're going to be living in a controlled environment, but it's not like that at all. I mean, I like living indoor, outdoor as much as anyone, and the great thing about Australia and even Victoria is that 80% of the year you can do that, but for the other 20% of the year where it is really, really hot or really, really cold, relatively speaking, you can close the building up, you can rely on your HRV, and you can feel super comfortable. So.
Absolutely. Let's have a look at one of these doors, mate.
Yeah, so this is a conventional European lift and slide door, so and becoming much more conventional in Australia.
So that actually lifted up when you tilted that handle.
Yeah, that's right. Yeah, it's got a spring-loaded mechanism in it that raises the sash off the runner. Obviously, you want the sash to sit back on the runner when it's not in use because we want the air tightness. But when you want to actually open the door, you want it to raise up off its seals and be able to run nice and smoothly. So this is a perfect example of, like, there's a few big lift and slide doors in this building, and that's because the clients want to obviously be able to enjoy the indoor-outdoor experience.
And this is where you're talking about the ventilation. We've just opened up that door. You've incorporated a fly screen on a track on the outside. Yeah,
so we're actually in a high bushfire danger area here as well. So it's really critical that to meet the bushfire standard that we have screens on operable doors and windows, and they all need to be stainless steel, obviously, to meet the bushfire requirements. So all the doors and windows have screens accordingly, and obviously that's pretty handy for the amount of insects we get and flies we get down here too.
We all love a good blowy, don't we? Okay, Dale, we're coastal. We've got such an amazing view. It looks like we've got no frame on these two windows on the junction. Can you explain that?
Yeah, so the predominant view here is southeast, and the house has obviously been designed to pick up on those views as much as possible. And part of that was creating exterior glass junctions that are frameless, essentially, which is something that's not seen a lot in triple glazing. It's a pretty, not a hard thing to do, but it's pretty unique in triple glazing, and Phrasing are quite good at it.
Because you've just got you've not obstructed with this view, and it really opens it up, doesn't it?
You obviously still have the warm edge spacer in the corners because it is triple glazing. You kind of have to do that, but that's quite like an external corner frameless glass is quite an Australian design trait. Like it's in a lot of Australian buildings, but traditionally it was always done in structural single glazing. Doing it in a triple glazed panel is more difficult, and it needs to be set up in a certain way that the warm edge spaces are kind of hidden in a way, and you still do get a little bit of an effect of some sort of structure there, but obviously that's the nature of having...
Glass is glass, mate, you know.
Yeah, and this is a 54mm glazing channel, you know, like there's two 18mm cavities in this glass, so, you know, we want the U value of the glass down as low as possible, around 0.56. There's offsets.
I think the compromise is understandable. Normally at that point there, you'd have a beam or you'd have some steel. So the whole process and the CLT and the overspanning, that's obviously all been incorporated in the design.
Yeah, absolutely. Obviously all the CLT gets engineered early. We've got quite a big counterlever here. In the CLT, all of the loads on that counterlever were factored in really early in the piece. Being Australian, we love Australian hardwoods as well, so we've got a lot of Australian hardwood designed into this building, which all comes from a mill locally. It's reclaimed pylons out of the Yarra River largely, or it's messmate that's come from windbreaks in the southwest region. all of those loads had to be factored into the CLT as well. So, you know, we had to give the engineer, okay, we're going to have 80 kilograms per metre squared of timber loads on all of the CLT. So all of that gets built in to make sure that the CLT can actually withstand taking those loads. Yeah.
So Dale, not only the thought process with the CLT, the building envelope, that construction process, internally with the joinery, everything looks very minimalistic. We've got so much storage in this space, and you've got something hidden in the overhead cabinet there.
Yeah, thanks, Jamie. Like, it's important to us, like, I think part of the design aesthetic of Australian architecture is that it is relatively minimalist, and as an architecture student myself, like I quite like that design aesthetic. What we're trying to do is, I suppose, push the bounds a little bit of introducing passive house and really well insulated buildings into an Australian aesthetic, architectural aesthetic, and part of that is minimising things as much as possible, minimising services as much as possible, and consequently, in this instance, we've done this a few times now, but we design where we do have to have a little bit of heating or cooling, top-up heating or cooling to meet the heating degree, to offset the heating degree hours or the cooling degree hours. We generally try to incorporate mechanical services into joinery where we can, or into spaces where they're not obvious, at least anyway.
I've just grabbed Al off the side for him to just go through a few of the details with this building envelope, and we've got some CLT panelling. Now, we've had some penetrations through this, which is part of our air barrier. Can you explain to us with PowerPoints, switches, what you've done to seal the CLT?
Well, with the CLT panelling, we didn't want to have any visible powers coming down through. So through a surface cavity in our ceiling, we've penetrated the CLT on the outside, run it down the outside, and then come back through from the outside to the inside to then run the PowerPoint. Those two penetrations have both then been sealed to alleviate any airtightness issues there.
And looking at this timber ceiling, mate, it's amazing, but I can see there's multiple penetrations, there's lights, there's fans. What have you done with the air barrier on the ceiling, and what's this ceiling finished with? It looks amazing.
This ceiling is messmate battens that have been finished with a hard wax oil. They're sitting on a ply substrate that we've had painted, and that's actually sitting on a suspended ceiling above another airtightness layer. So there are two frames here. The upper frame is carrying an airtightness membrane with insulation above. Behind the plywood is then our service cavity, so that's carrying all our HRV ducts and our lighting.
Yeah, so you've literally got a whole service ceiling, and you can penetrate it where you need to without compromising the air barrier.
Yeah.
And John's been out on this project a couple of times, so we've gone through some of the processes, but you know, I get to see the finished product, and you know, it looks absolutely amazing. Here we've got CLT meeting the window. How have you connected these two systems together?
Okay, well, this is our solid CLT mass. We've got a small reveal which has been cut in neatly against the window to create this detailed edge. Then the window frame is taped on the outside of the CLT, which then gets hidden by a cladding system. So we can take care of airtightness in this instance on the outside, and then still keep that neat streamlined finish on our inside.
On the outside, we've got a charred cladding. So what's the detail between the charred cladding and the CLT? Because obviously we've got services and everything that's running between the both. How's the system between the charred and the CLT on the inside?
Directly to the outside of the CLT, we took care of the airtightness, so our taping and sealing is done. Then there's a 100mm wood fibre insulation board, and then that gets wrapped with our weather-resistant barrier. And then taped again to the windows, so any driving rain or throughout the building process, the CLT is protected and the building's protected. And then our cladding system of that charred ironbark is sitting on a vertical cavity batten and then a horizontal batten. So there's 55mm of some framing on the outside of the Gutex, which then holds our cladding system.
It's a fault-proof system, really, isn't it? How did you actually get this floor box through the air barrier?
Okay, so the floor is 200mm thick CLT panel. But yeah, where we have recessed this floor box in, we've cut it out. The power goes straight through the CLT and is sealed from underneath, which then gets covered again by our eave structure.
Some people might be asking, why do we have a floor box when we could easily install PowerPoint on the CLT like we've done in other rooms?
Well, this actually was a later addition in the design, and we'd already finished our external cladding and detailing there. So to get to that external wall of the CLT was impossible, although we still had the floor underneath that wasn't yet completed. So we were able to use the floor structure to get through instead of using the wall.
All right, Al, this is an amazing space, isn't it, for a bath and a shower. Talk to me about this detailing here, mate, and why you've chosen to go with this curved brief.
The curve really softens the space. The brief to us was to create a cave with a small crack of light, so then we can spend some time in the bath. And we're able to achieve this by introducing the curve like an upside down half pipe. We then also played with where our batten covers the LED to then control the amount of light that we've got coming through, create this effect.
Tell me about this, mate. We've got a bed and it looks like it's just transformed out of the CLT, mate. What was the process of this?
Well, yeah, the customer wanted to entertain the option of using a piece of CLT as a bed base. So we thought, yeah, why not? Let's do it. And then in that process, we've designed a built-in joinery unit, which then incorporates what they wanted to have in their master. So we have some drawers that have concealed power points inside them, and we spent a bit of time drilling 132 holes to make sure we've got adequate ventilation for our mattress, and I think it's turned out pretty well.
I don't think you're going to get any sag in that base, mate.
Nope, no squeaks, no sag.
Okay, Dale, we've gone through a bit of a run through. Now, we've done the blower door test. What's the process now for your passive certification? Because, you know, we've got some amazing results. It's all been documented. Your build's been documented. What's the next step for you to get passive certification for your client?
Yeah, so it's pretty rigorous, Jamie. Throughout the whole build, we're documenting as we're going. We're recording mostly photographically what we're doing, installing the CLT, because the CLT here is the airtightness, obviously. So making sure that we take photos of CLT junctions, how we're caulking those, taping those, whatever we might be doing. Where the Intello went in here, the Proclimer as a ceiling layer, making sure that's all documented. Making sure as we're installing insulation, we're taking photos of the insulation, taking photos of the stickers on the bags to verify that the insulation that we said is going in the PHPP,
the right R value,
being installed.
Sure.
Domestic hot water lines, so where all your services are running, making sure that all of those lines are insulated and showing how much run there is of those lines. It's super detailed, and it's one of the things that I love most about Passive House is that you know if you build a passive house and you get it certified, it will perform.
It is a passive
It'll
house.
perform the way it says it's going to perform in the PHPP, like literally down to the wattage hours. It's a really rigorous process, and it'll probably take us another couple of months to get this across the line, because it is like just a huge amount of cache of documents uploaded to the certifier. Detail Green will be certifying this one, I believe. Sure. We actually work with Hip v Height. Marcus at Hip v Height has done the preliminary PHPP, the working PHPP with us. Whilst we're passive house designers as well, we still like to get an outside independent person to work through that process with us, just to cross-check and make sure we haven't made any mistakes, that all the boxes are ticked. Then it goes to Detail Green, who then do the certification and upload all of the documentation to the certification platform back in Darmstadt and Germany.
Wow, it's an achievement, isn't it? It's an accomplishment for yourself, your client.
Yeah, absolutely.
And it's just the final step to the process, isn't it?
Absolutely, yeah. And look, it's not to say that you have to have certification. Like we've built numerous buildings that haven't been certified, and the client hasn't wanted them to be certified, because it's an expensive process as well. You know, it's a
of course
$10,000+ process to go through and do all that documentation.
Yes.
So not every client wants it. So for certain clients, it's really important to them. For us, it's important because it's
the cherry on top. Really.
Yeah, it solidifies the fact that we've put all this time and effort in, and we know that we've achieved what we set out to achieve.
That's your reward.
So it is definitely a reward for us, but it is not the be all and end all either. Like if you design and build a building to Passive House standard and you do what is required, whether you have the certificate and the plaque that says it's certified, the building will still perform.
It's going to perform
as a passive house. Yeah. We want to build buildings that will hopefully be here for many generations yet, and that we can be proud of and hang our hat on.
Fantastic, mate. Well, thank you so much, Dale, for
Jamie.
Bringing me
Thanks
through.
for coming down.
Your team should be very proud of what they've produced here. So
absolutely. Thank you. And importantly, I'd just like to say that, I don't spend anywhere near as much time on site as I used to, and this project is just, like it's obviously a credit to our design team, but it's a credit to the guys on site. And
Oh,
Alistair in
absolutely.
particular, who
Yep.
spoke before, like he's really driven this project. Reece Day, our project manager, just amazing work to deliver such high quality and such a building that performs so amazingly. And it's a credit to our clients as well. I mean, not everyone has the vision and the dream to do something like this. Admittedly, not everyone has the resources to do something like this, but they do, and it's really nice of them to share that with us, because without them we wouldn't be doing any of this. So.
Refreshing to get the opportunity to build something like this, mate.
Absolutely,
it's really good to to be able to build quality and not quantity. So
absolutely,
fantastic,
sure.
mate.
Yeah, it's a privilege, that's for sure.
Can't wait for the next one. Thanks again, Dave.
Thanks,
Cheers,
Jamie.
mate. Thank you.